Hello, everyone. My name is Adam Woods McCormick, and I'm here to talk to you about how we at Sinclair Broadcast Group leverage Redis for system monitoring. I know what you're probably thinking. That sounds boring. Hopefully, I can dig into how Redis works under the covers a little bit, and you'll see why solving this problem was not as boring as it sounds. First, a little bit about me. I'm a principal engineer. I've been working in software for 20 years now, and I started writing tools against Redis when Redis was brand shiny new. So it was a little weird coming back to Redis after all of that and finding out that the way that people looked at Redis now is just completely different from the way that we looked at it back when I worked on it the first time. And as I think you'll see, that gave me a little bit of an advantage. We were able to solve a couple problems that we wouldn't have been able to solve otherwise. But yeah, to the presentation. So once again, I'm here to talk to you about system monitoring. Always a pleasure to meet new people, and doing a presentation like this is quite a lot of fun. At Sinclair, we run really lean, so I've built a lot of these pieces myself, and it's always a good time. It's always fun to show them off. A little bit of background on what we're going to be talking about. First off, again, it seems like monitoring should be such a simple thing, but it's always difficult to convince people to do monitoring instead of just building more things. And more than that, when you have as big of a problem as we have, as I will point out in our second section, you actually have to really think about how you're going to handle the problem. So architecture is a critical piece of everything that we do. Then we'll do a bit of a technical dive, look at some code, even compare and contrast some code from way back in the dark ages of 2009 when Redis was a shiny new product. And then some lessons learned, really business payoff. Why on earth it was worth doing all of this for the sake of our business. First, a little bit of background. I'd like to start with something controversial first. And that statement is this: Redis does not have an API. I know what you're thinking. You've used Redis's API, haven't you? You know it. But, when we think APIs in the modern software world, we think REST, or we think a particular protocol that we can call over a REST-like interface. But it turns out that Redis's protocol is actually serialized text. Now, for those of us old fogies who once connected to servers via serialized text and teletype, that wasn't a problem back in 2009. And as we'll go over, there's some genius there. Well, so you might say, okay, I'll amend my statement. It does have an API. Redis doesn't have an SDK. And that's actually where the critical bit is. What Redis has is a lot of client libraries that enable your platform to talk over a socket connection. Now, I find that a lot of people living in the modern software world don't worry about how their connection happens. They just let their software make that connection, which is great until you find something that the current software libraries can't do, which in our case is very important. So the reason Redis does this is that it's kind of a secret sauce. The low overhead of a teletype, basically a line level text protocol, makes changes really, really fast, especially when you don't have a huge amount of bandwidth. And as I'm about to discuss, that's where this all came from. So let's go back in our Wayback Machine. Let's look at Redis, the Redis lack of SDK, and go back to 2009. So for those of you who've been programming since the 90s, you'll remember 2009 as sort of a cleavage point. Maven had just led to the creation of a lot of other package managers. There was a profusion. NPM, Maven, Gradle, 40 other package managers and really builders had just come into the fore, but no one was really using them yet, and people were literally afraid of them. Bandwidth, still very expensive. Microservices was not a common term in 2009. In fact, though it was coined in 2005 by Peter Rogers, it wasn't widely used until nearly 2011. And even then, really only in very niche architecture circles. And there were still some of us who used teletype to interact with real servers. And really, we all still thought Maven was pretty spiffy, and we were still trying to get all of our various companies to endorse Maven. So if you wanted to use Redis, you had to learn it. You had to learn the protocol, you had to learn how the servers looked at everything you did. HGET, HSET, HDEL, all over the place. Here's a little example of 2009 Redis code. Now this is using a very, very young version of the Redis client library, but notice all it is a very, very thin wrapper on Redis, on the Redis line level protocol. There's no encoding, there's no searching, there's no types, there's just sets, gets, deletes. And you could get subsets, so you could get a subset of a hash, but you couldn't get anything unless you happened to know a priori what you were asking for. So you saw a lot of code like this. No schema management, everything's just strings, lots of parsing, lots of mapping, lots of extraction. And please don't judge me for this code. It's really, really old at this point. But there's no searching, nothing's done with promises, it's callback hell, no types. I mean, it's old, but the thing is that you could write a microservice, what we would call a microservice now, or a Lambda, against this line level protocol, and it flew. Compared to all the libraries that dealt with databases and all the SQL, it was so refreshing to be able to just store things and then read them just like they were in memory, and knowing that they'd be there if and when your server got restarted, like mine. Now I used to do this on Heroku, so there's some niceties that provided, but even so, I had to learn how all this works. But now that we're in 2020, so surely, our lives are easier, aren't they? What do you think? For my money, I still say that Redis doesn't have an SDK. What we've done is made the server much smarter. It handles more data types. You can edit subsets of items. It understands more about your documents as you store them, and it has sharding and multi-tiering capabilities. There are so many tools built on Redis, so you can sell it easier, and you can make it act like anything: a database, a message bus, a cache. And there are managed services for it, which is part of the reason why we were able to adopt it. Redis Labs, others make it extremely easy to adopt Redis without having to have a technical architect around to do it for you. So a little bit background, now that we've understood sort of where I came from on Redis. This is Sinclair. We manage all sorts of different websites, lots and lots of websites. We have 193 news brands and more than 10 entertainment properties. That includes movies, it includes magazines, it includes newspapers. At any given moment, we have something like 10,000 active pages. But our archive, which is to say all of the pages you could ever have to visit, is close to 17 million pages. And that's not actually an exaggeration. Every one of our sites publishes upwards of 1,000 stories in a given week. It's hard to keep up with in actuality. Every 15 seconds across our entire network, there's a new story being published, which is extremely fast if you think of most sites you might visit on the internet where you might get another story every hour or so. We have one centralized CMS that manages all of this, and any particular piece of content we can syndicate from one site across our entire network up to 600 different locations for extremely popular stories. And we have a very strict SLA that says that we have to publish to our audience within 1 minute. That means that our system has to be highly cached, but it has to be very, very nimble. We can't go down, we can't leave things running. We have to make sure that when we publish, things happen. Because we work at the speed of news, everything's burst. There's no predicting when a story is going to need to be published. So there isn't, and as you'll see when we get to the problem section, that makes life hard. With 3,000 news and entertainment producers, we don't have the opportunity to coordinate as humans. We have non-technical users, which means we get a lot of duplicate events. The system is not allowed to go down by federal law. It can mean multi-million-dollar losses to breach the public trust or to have outages. It also means that while we have quiet time in the middle of the night, there's less than 85 minutes between our last broadcast and our first broadcast of the day. And news can happen anytime, be that Christmas, the middle of Saturday morning, or on an idle Tuesday. This means that any of the systems that we build have to adhere to this very strict, always-on kind of schedule. And so monitoring for us becomes a critical portion of everything we do. For the sake of this presentation, we really had two problems we were trying to solve. We want to know whether we meet our SLA. That means 1 minute from producer submits a story to visible to the audience. And we need to know, given a producer looking for syndication, what's happening right now. For the SLA enforcement, we have to be aware that we have an n-tiered architecture. There are multiple levels of caching and CDN. And we have to have resolution and alerting that can be used by automated systems, because with 3,000 news producers, we don't know exactly who needs to be notified at any time. We also can't get in the way. So whenever we do these real-time, very broad publishes, we can't tell them to slow down, and we can't wait to visit all these places. We have to scale. So some thoughts that we went through when we started thinking about how to do this in a usable way is we're monitoring websites from a web tool, and we knew we wanted to use Redis as a cache for some of this stuff. Could we do that directly from the web? We found that there isn't a REST API for Redis. As I pointed out, it's not built that way. So there really isn't a web client for it. And it seemed, which I found odd, that people forgot that the Redis API was inherently just a serial socket. You don't actually have to use a client to talk to Redis. And since WebSockets are just serial text interfaces, all that time I spent trying to rig up MUDs to be usable through the web was going to come in really handy. Our basic architecture takes advantage of that. The core idea here is that we're going to operate a system from the audience's viewpoint. We're going to hit every relevant page, and we're going to publish everything onto a event bus and a cache. We use a little bit of redundancy here because we don't want to get too far off base. This is a brief into our architecture. Really, there's two pieces we're going to talk about. The monitor here. Hopefully y'all can see that recorded. And the bridge. These are the two big pieces of software that we built. Now, there's more I've included because it's useful to know. We have a CMS, and that CMS gives us a back channel so we can limit what we're watching at any given time. That helps lower the difficulty of monitoring all of our pages. And we use a direct forward channel to mirror the Redis update so that we know if Redis goes down or if Kafka goes down, that the message will get through one way or the other. It lowers our risk, really. We're going to dig into a little bit of technical. I'm going to try and keep this short because code, while it's fun to look at, is not so great to talk through in a demo or a presentation. First off, we've got our monitor service, one of the two big systems we built. The critical bit of sharding a big data problem, and anyone who's dealt with big data, I'm sure you can stand up if you want, I won't see, initially is that each node has to have a set amount of responsibility. And in our case, we just set that statically because this was a proof of concept. We weren't trying to build a super huge system to start with. But each system took a shard, basically one of our sites or a few of our sites. And their purpose was to monitor that subset. They visit every single page in turn, they record some information about that page, and then they process the information they find to figure out whether the page has changed and whether the SLAs are being met. The critical problem is you have to figure out how many nodes you need. Here's some math. I'm going to skip through it real quick. Basically, for every node, you can visit something like 100 pages in every 100 seconds, or every 30 seconds. And since we need to visit 10,000 active pages, that means we need somewhere in the realm of 100 to 150 threads. Maybe my math is not perfect here, but it doesn't really matter because we're probably going to double it anyway. That's software. And then we need a single unified view, and it needs to be able to scale to reach the audience. So here's some code. This is the first piece of the monitor code. What it's doing very simply is pulling each page, putting it into Cheerio, and then processing the page to get a hash of that page, and then comparing that hash with the last time we visited this site. For every one of those pages that changes, then, we go through and we find all of the stories that have shown up for the first time, and we put them onto both our Redis cache and our Kafka topic. And you can go back and look at this. I'm pretty sure they're making all this stuff available, so I'm going to fly through here. Second half of the problem is what I call my serial bridge. What this is going to do is it's going to bridge from the WebSocket to the Redis socket. That still requires a server, but it can be pretty low cost as servers go. And you can scale it as much or as little as you want because you can, once again, shard your clients across however many you want. We use a little bit of the Node.js nomenclature for the way some of this stuff works because we're using Webpack, but generally, it's just web. These are all web native technologies. So the bridge, here is the real secret sauce here. Whenever you try to open a WebSocket connection to a server, it does what's called a socket upgrade. Don't know how many people ever deal with WebSockets out there, but that's how you go from a request that is effectively REST because it's HTTP or HTTPS to an actual WebSocket, an open bidirectional text protocol. We establish a heartbeat so that if our clients stop connecting, we can shut down open connections so that we don't waste any of our capacity. And we manage the whole lifecycle of the server and client relationship. And that way the web can send us requests. We construct the client relationship. Now notice there isn't a client library here. We're building a NetSocket. This is native Node.js code. It does not use a Redis client per se. It is using a bare socket. This lets us do a direct bridge from a WebSocket to the Redis client and just intervene to parse the messages a little bit. And the next slide I'll show you how that message parsing works. But you can see here we're managing life cycles and we connect directly to Redis as opposed to trying to use a client. And the real nice bit of that is this next bit where suddenly from our web client we talk in JSON or we talk in strings. All of the processing happens in this intermediary, and then we talk line level protocol to the actual server. Now, if we want, we can do all of that protocol speak on the web. We can talk Redis protocol. We can do gets, sets. We can do deletes. We can talk the line level protocol if we want through that WebSocket, or we can encode our message as an object, which then lets us use something like TypeScript, or lets us validate that our content is coming through correctly. Notice we have some validation in here where there is a response type that we do and don't support. That lets us make sure we're not getting nonsense and make sure that if this piece of our system goes wrong, we're not breaking the core of our monitoring. And then at the end of all of that, we write it onto that socket bridge, which means that we now can talk from a web client directly to Redis. Now, so lessons learned as we try to do this. One of the biggest problems we had was that we tried to host Redis ourselves. And hosting Redis ourselves meant that we had to intervene more than we should have. Redis itself worked great when our server stayed up. If we had it all over to do again, we would probably have not tried to stand it up for ourselves. We would have put it on a managed service like Redis Labs or one of the other Google solutions or AWS solutions or even Microsoft solutions would have been better than trying to host it on an actual box. We also found that if we didn't think of Redis as a cache, but instead as a data store, there were lots of solutions we could find that opened up. Even things like just thinking of it as a way of communication. The fact that you can take an alert off of each of your tables and use them as a communication mechanism meant that we could talk between our servers as a redundant signaling mechanism. And the last one is really just don't overthink your data. I see a lot of Redis implementations that are trying to leverage every bit of the JSON editing and the search capabilities and the relational data storage, but Redis is still fabulous if all you ever do is use it as a key value lookup. And with a lot of the tools that are out there, you don't have to try and guess too much. If you over-optimize, you actually can get a lot worse performance, and we saw that as we tried to build replication in from the beginning, and things just fell over. Mostly, if you let the system work and you let the managed service do what the managed service does, everything worked out better. That's about all I've got. I hope that you learned a little bit about Redis and you'll think of Redis more as a core technology and you learn something about how Redis views the world, and maybe you'll think about bridging, dealing with it more like a teletype machine and less like a database one of these years. I hope everybody learned a little bit. I hope you aren't, too annoyed by me. Thank you all for listening, and hope you have a good day. Stay safe in quarantine, please.